we're inviting a number of projects, Astria, Eigenlabs, Anoma, and Espresso, but we're also inviting Frax to discuss this from the roll-up and application perspective. So we're getting two sides of the coin here. So I'm gonna let Kaido take it away, and this is the sequencer and interop panel.
All right. All right, hi everyone, can you guys hear me well? All right, so why don't we start with a quick intro from everyone on the panel and just also a brief, maybe 3 sentences on what's top of mind for you. What do you think about most nowadays? Why don't we start with Sam?
Cool. Hey guys, I'm Sam, founder of Frax and co-founder of Fraxtal, which is a modular roll-up with fractal scaling tech. And what's on the top of my mind for me is the application, app chain, blockchain, and modular lifecycle.
Yeah, I'm Adrian. I'm one of the co-founders of Anoma. I think top of mind for me is long-term privacy guarantees to make the space actually usable for real people in the real world, not for lots of shitcoin trading where privacy is probably relevant, as well as sort of what the long-term equilibrium structure looks like between globalists and sort of sovereignists, where how much shared security do we actually want, how much individual sovereignty on an individual as well as on chain level do we actually want.
I am. Hello? Okay. Hear me? Do you hear me all right? Okay. I'm Ben Fish. I'm the CEO and co-founder of Espresso Systems. And as I opened today, if you were here at the beginning, was saying, I think that the biggest challenge of 2024 is regaining the unity and interoperability of the Ethereum L2. I mean, that is what makes Ethereum as an ecosystem so valuable. That is what differentiates Web3 from Web2. And just going off the topic that the DA panel teed up for us so nicely, right? How do we maintain chain sovereignty while also having this experience of being one collective ecosystem, Ethereum? What is the difference between, like, can be done just with asynchronous composability bridging? How do we make bridging not be 5, 10 minutes or days, but actually if just a few seconds? How do we minimize trust to get there? And how do we, as Sriram so elegantly said, how do we have synchronous interactions as needed when we need it, right? And so that's what Espresso is all about building. It's building a marketplace for that.
I'm Josh. I'm the co-founder at Astria. We're building a shared sequencer network primarily focused on the Celestia ecosystem. I guess things that are top of mind for me, a lot of it is kind of developer experience and kind of how do we make it easier for developers to build more novel things, since it feels a little bit like we've been stuck in kind of, especially in like the roll-up space where we're deploying a lot of different guest nodes and then maybe we have contracts on top of that. How can we kind of use shared infrastructure to allow for easier interoperability and easier bootstrapping of kind of more interesting novel state machines?
Awesome. I'm Kaido. I do research at Eigenlabs. I focus on AVS design most of the time. All right, we have a great panel here, so I'm going to start with some questions for the shared sequencers. We have the shared sequencers here, and we have the roll-up and app chains there. So first question, if you have to give advice to the L2s who are thinking about launching an L2 or thinking about launching an app chain, what's your advice to these people who are launching these chains, specifically around sequencer design? Let's start with Josh.
I guess like consider the trade-offs, and again, why we focus on like developer experiences. Coming from like a Web 2 background and being in Web 3, like 3 years feels like a short time and also a long time. What is it actually going to entail to like integrate, what you want to build with a given system? What are the trade-offs you're going to make in kind of design and, also in like the functionality of the system? What can you build based on like what integrations are available? What are you getting out of the box? What does it cost you in resourcing or like developer time? What are structural trade-offs like, latency of a centralized sequencer, latency of a decentralized sequencer? What upside are you getting from, interoperability guarantees or higher security guarantees? And just kind of do a top-down evaluation of like what are the options on the market and what are the trade-offs you're going to make by picking one versus another.
Ben?
Yeah, let's come back to just the users, right? If you're building an application, what you care about is the user experience of your users. And what users want is a safe, secure, convenient, easy experience. They want to be able to accomplish their intentions, not necessarily having to think of the fact that they're locked into one ecosystem or another, but they just want to be able to transact with other users of Web3, with other users of the greater Ethereum ecosystem. And so this is going to be enabled to the greatest extent by rollups or L2s that enable the greatest unity and interoperability with everyone else, not only in the L2 space, but also at the layer 1 itself. And so I think the predominant thing to think about, because all these different rollups, right, they're achieving much of the same features, right? There may be a dichotomy between optimistic versus ZK, but optimistic rollups may eventually integrate ZK proofs at some point. And each of these different SDKs have their own advantages, but ultimately what's going to differentiate the ones that are going to have the best user experience from the ones that are simply not going to are the ones that are part of and most aligned with the greater Ethereum ecosystem.
I think from my perspective, especially when you look at sort of the L2 and L1 space here, I think everyone keeps saying the road to decentralization, eventually we will decentralize the rollups. Like currently, pretty much all optimistic rollups are like 3 out of 5 multi-sigs. They're like very centralized, effectively L1s. I think sort of this distinction is going to go away between L1s and L2s because to a large extent it matters what the security model is, and like in the current landscape, the security models for most L2s is kind of atrocious. So I think if you're looking into building a new execution environment, like one of the most important questions to ask is actually like, what is the security model you want to have? And if you claim that like you will decentralize eventually, I have my doubts that you can achieve this because decentralization is the actual hard part. And if you design your system around, we'll decentralize this eventually and think about the hard problem eventually, you will just never do it. And even if you try then in like 5 years to do it, you will have made design choices that are going to make your life close to impossible without revisiting sort of all the work you did in the last 5 years. I mean, this is like, I think also from a user perspective, this is maybe an open question. Do we actually want self-sovereign infrastructure? Or do we want to like have these very fast L2s that are run by effectively single signing keys? This is mostly a question for the users, right? The other thing I would consider is, especially in the interoperability space, don't hand-roll your own interoperability protocols. I mean, currently everyone hand-rolls their own bridge, and this is hard, and no one is reusing any code here. Shout out here, if you're doing this, please don't roll your own bridge, just use IBC. IBC works to like a one-on-one multisig, it's fine. It's just a fully specified protocol that you can use for interoperability message passing.
Yeah, so I think Josh actually brought up some really good points. A lot of you guys might be familiar with Frax. We're everywhere on Ethereum mainnet. We're stablecoin, LSD, kind of DeFi platform. So when we wanted to design our modular rollup from first principles, we thought about a lot of the things that everyone on this panel and the previous DA panel has been talking about. And so the main thing that I think of in terms of long-term life cycle of app chains and modularity is that there's a lot of apps built on some general purpose chain, and those apps, some of them get really big, and because launching your own blockchain is basically like deploying a smart contract now, right? Or if it's going to get as easy and easy in the near future, some of those big apps are going to want to be an app chain and capture some of their, either depending on how they capture block space, MEV, whatever, or anything like that, right? And so some of them go out and launch their own app chain, and then when they get big, they try to turn into a generalized chain, right? And so they invite everyone and devs and everything to build on top of their app chain. Then some of those big apps on that generalized chain now starts to think about deploying an app chain, right? And then you kind of start back at step one. And so we thought of how do we actually capture this cycle in an unopinionated manner and actually bring value to people that are in any step of this actual app to app chain cycle. And so when we launched Fraxtal, which is launched in early February, what Fraxtal is that it's a EVM execution environment and a special Fractal module that has settlement, and so it aggregates consensus with ZK proofs across different app chains or L3s that want to settle on the Fraxtal mainnet. It's somewhat similar to Avail Nexus, but the difference is that Fraxtal is totally unopinionated about what DA solutions we use, what roll-up frameworks we can allow it to settle on. And the goal here is that we want to actually create this settlement black hole for assets that are M2 money, right? App chains that are issuing yield, app chains that are perp dexes, anything like that. And the way that we want to do it is not by competing with OP, ARP, Starknet, and any of the DA projects and the big boys there, but actually integrate as many of those in compatibility as we can to actually allow this app chain cycle and users that are thinking of launching an app chain to pick any modular component they want, whether it's a Veil DA, Eigen DA, Celestia DA, and then finally settle on Fraxtal for the reasons that we think is important, which is M2 money, settlement of value, and deep liquidity.
Awesome. There's a lot of different topics here, so I'll try to go to different points. Why don't we go back to Sam? You mentioned about Fractal. Can you talk about more about, from when designing your own sequencer, what were some design choices you've made? Like what are some, like, maybe the second choice you didn't go to, and why didn't you go with that choice?
So right now, when we launched Fraxtal, it's pretty much an open sequencer design. It's OpStack, and we're really looking to decentralize the sequencer using something like Espresso over the long term. And the goal here is to make it so that any actual app chain, L3, or anything that actually wants to settle on Fraxtal does not have to necessarily be locked in any kind of DA or specific sequencer model, but as long as they actually push the state of the chain to Fraxtal mainnet, that's where the settlement actually happens.
What do you see the biggest, bottleneck when moving from, centralized to decentralized? What are the main drawback in your mind?
Yeah, that's a really good question, because any layer that you're building has this drawback, right? Whether you're building an L1 app chain rollup, a DeFi platform, all of these things. And I think the most important aspect is having just a very clear roadmap of being able to integrate with solutions that show up down the line in the real world, right? Very few of us know exactly what the crypto space will look like in about 12 months from now, right? If we were here 12 months ago and we were asking, do you think Bitcoin would be like integrated a bunch of ETFs, the modular roadmap would be this mature and evolving, I don't think any of us could actually predict it that well, right? And so our view is, we know we can't predict the future, but we want to keep an unopinionated design space for Fraxtal.
Awesome. Now go back to the decentralized sequencers. What do you think? How do you think, when people are choosing between centralized versus decentralized, what are some trade-offs? And when there's pros and cons, how do you address the cons of the side of the question?
Yeah, I can take this. So I think that when it comes to talking about decentralization, there's a lot of different dimensions that we should think about here. So take, for example, what Espresso is. Espresso is actually not just a decentralized sequencer. I mean, we think of the sequencer for rollups as this server that collects transactions and then batches them and posts them. Espresso is not replacing the job of that sequencer. Rather, what it's doing is it's creating a marketplace for rollups to be able to sell those sequencing rights to other parties who can create more value from that. And that is part of decentralization, right? Part of decentralization is being a part of an economy, not being isolated and just myopic and producing the blocks for your own rollup, right? It's being able to be plugged into that greater Ethereum ecosystem, which can generate surplus value. And the second element of it is security. So if you have a marketplace whereby people are selling the block space for their different rollups, and other parties are coming in and then sequencing for rollups, how do you know that these sales are actually final, right? I mean, a sale. How is a sale credible? How do you have credibility within an ecosystem like that? If you have an economy that connects sovereign chains, how do you have credibility, right? If you had a situation where one chain sold its block space and then decided, oh, actually, you know what, I'm going to peruse the block on my own, even though I sold it to you. So you need to have a unified way across an entire ecosystem of having shared security on finalization. That's something that Ethereum provides. It just provides it very slowly. So Ethereum provides finality after 15 minutes. So when I think about the second aspect of decentralization, beyond the market or the economy I'm talking about, it's about having a very, very secure as secure as Ethereum way of agreeing that something happened. Okay, and that's the second thing that Espresso is providing, using EigenLayer to bootstrap as much of Ethereum security as possible. Let's get everyone to agree on what the hell happened. That's decentralization.
Awesome. Josh?
I guess going from like if you started a centralized sequencer, you want a decentralized sequencer, there's some useful just like first principle thing, like what is a centralized sequencer? Would say like there is a box, and that box is in charge of ordering transactions. There is one box. If you want to decentralize that, there is more than one box. It's like definitionally, it costs more money to run multiple boxes than it does to run one box. They're doing the same thing. It's like when you think about this, like there's some just like first principles, like it will cost more. Kind of why when we looked at like decentralized sequencing and kind of expanded into shared sequencing, it's like, well, okay, we have to run multiple boxes. Can we kind of amortize the cost, right? You know, and kind of to a lot of the discussions here about like how we see ecosystems develop, like, you know, the kind of like pithy quote in like business terms is like there is only bundling and unbundling, and like the business cycle is just like, hey, we have unbundled two things, now it's modular, now you have box A and like box B, and then you say, oh, well, actually now I have grown large enough as like box A, I would like to integrate like box B and vertically integrate that, right? And we're just going to kind of go back and forth, like this is not like a blockchain thing, this is just like how the world works, you know? The easiest example, look at fast food menus, like is it doing like a value menu or are you doing like a combo meal? Like they just do this on like whatever, like a 3-year cycle, and you're like, why? Like I don't know, that's how business cycles work, that's what people like to do. And so in the trade-off, right, it's thinking about like what phase of this are you, right? You know, one of the reasons that, you know, our project Asteroid came out of the Celestia ecosystem, we haven't spent time going to like, you know, Optimism or Arbitrum or like zkSync and saying, hey, I want to sell you a shared sequencer, because from like a market positioning thing, they are kind of already above some point where they're a sufficiently large kind of ecosystem or project such that if they wanted to kind of build this, they have the capacity to build it themselves. They are already at a sufficient scale to vertically integrate. We're much more interested in saying, okay, we think we have like new abundant block space provided by Celestia. How do we provide the tooling such that the projects that are able to take advantage of this can do so in a way where they're not doing this, you know, we're going to decentralize over time. They can be decentralized by default by saying, I'm going to build my tooling and I'm going to start with something that is decentralized.
Adrian, I want to go back to you about, yeah, go for it. No, I was going to go back to you about, you know, you're arguing that if we start centralized, it's basically impossible to move back to decentralization. You want to elaborate more, you know, given the context we just discussed here?
Yeah, I just think like the economics play against you because you are sitting on this gold mine, which is the single coordination point. And I think there are very few incentives to go out of this. Plus the current designs, especially in terms of execution environments and that you're making, don't really lend themselves to be actually decentralized. Because you want something like Intense at the base layer so that it can actually have multiple solvers competing or doing joint solving, which is really joint sequencing on like I have some A to B, someone else has B to C. I can like do an intermediate sequencing, and then I can any random third person can take and finish the cycle and then actually submit this as valid state update on chain. So I think that's quite important. I think the other like to me, a lot of times right now, the L2s, like the sequences, what generally are like the centralized sequences, are really the finality guarantees, because it's like the single point that is allowed to update the actual state root on Ethereum. So I think when we think about shared sequencing, we shouldn't think about, like, there are two steps to this. Like one thing is provide finality and security, and the other one is to actually provide shared sequencing. And so on the shared sequencing thing, I think one important thing to consider is that shared sequencing only gives you inclusion guarantees, not execution guarantees, which means you can't necessarily do like dependent things, right? Like I have a hotel chain and a train chain, and I want to only book the train if I also get the hotel. If this is on two separate chains right now, a shared sequencing stack can guarantee that it gets included in both, but not necessarily executed. And this is something we've been working a lot with. It comes back to like fundamental distributed systems design, what we're doing with Typhon and Chimera chains, on not only how do we give execution guarantees, but how do we even get synchronous calling capabilities between two separate security models effectively. And this is really what Typhon does, where it's not, it kind of looks like a shared sequencing design, but instead it forms a virtual blockchain between two state partitions on either chain, and as a result, you can actually have like this contract on like the hotel chain call into the state on the other chain in a synchronous fashion on this like shared virtual blockchain, so you get full synchronicity and atonicity guarantees, and not just inclusion guarantees.
So I actually disagree with that. So I don't want to
I like
the
it.
flow, but
No, that's perfect. I was just about to ask you. Go for
okay,
it.
yeah. I think the industry has fumbled how it talks about shared sequencing. So like, let's go back to the basics. How do blockchains work? Okay, somebody gets elected as a proposer, and then they can build blocks across different applications. Okay, the number one thing, that's what we call a sequencer. That is the sequencer. It's the person who is building the blocks of different applications at the same time. Okay. The person who is building the block for multiple applications at the same time can do whatever the hell it wants with those blocks. It can guarantee anything that it wants. It can guarantee atomic execution. It can synchronously call applications. Okay, what Adrian is talking about, though, is if this person who's producing the blocks does whatever it wants, right, what guarantee does a user have if I ask that person to facilitate a flash loan for me or do something across different applications? What protections do I have as a user that guarantees this party is going to actually do that? Right? That party can actually promise to me, I'm going to execute your transaction on the Ethereum mainnet and on Arbitrum and on Optimism only if the price of Uniswap is X. Okay? It can tell you that it can make a promise to you to do that, but how do you know it's actually going to do that? Okay? So that's where we come into something that's not shared sequencing, but that's shared finalization, okay? A shared finality gadget that basically says, these are the blocks that were proposed across different chains, and that's not going to change. You can't change your mind after you propose these blocks simultaneously across different chains. That's what gives you what Adrian is calling atomic inclusion, okay? But if we just said, oh, shared sequencing only gives you atomic inclusion, we're missing the fact that rollups have just sold their block space to a party who can create tremendous surplus value by being able to guarantee things, conditions across different chains simultaneously and make those promises to users. In fact, a special case of this is that if you have ZK-proof systems, that party can facilitate coordinating messages passed between different rollups. You can imagine the proposer for the Ethereum L1 simultaneously constructing a rollup block at the same time that it's constructing an L1 block, and it's calling into the rollup, it's depositing into the rollup, it's doing things in the rollup, it comes out of the rollup, it withdraws from the rollup, it does something on the Ethereum L1, and it constructs proofs as it's doing this that the actions it took in the L1 produced a certain result. Complete synchronous composability can come from ZK proofs plus a coordination layer, okay? And shared sequencing is that coordination layer. It's what enables actors to coordinate the construction of blocks across different rollups simultaneously. That's what shared sequencing is. So anyways, that's my view on how we should talk about it.
Loved it. Ben, continue back to you. How does pre-com play a role there? And before we talk about pre-com, you want to give the audience just a general understanding what are pre-confirmations?
Yes, yeah. So a pre-confirmation is like, I just built a block for multiple rollups simultaneously, and as a trusted builder, I could give you a promise that I will do something with your transaction. For example, Flashbots often promises to users today that they won't pay for failed transactions. That's a certain type of pre-confirmation. It's based on your trust in the Flashbots builder. A proposer who acquires the right, whether it buys it or is enshrined with it, to propose for simultaneously for multiple rollups and even the Ethereum L1 can make any kind of promise that it wants, and it can strengthen that promise by staking a tremendous amount of collateral. Right? And in fact, it's not that different from what blockchains do today. If anyone tells you that blockchains are trustless, it's kind of a lie, right? Maybe trust minimized, but everything comes down to some belief in some either honest majority assumption or some huge amount of staked collateral. That's what everything stems from in the Ethereum space overall. And so if the proposer for multiple rollups and the Ethereum L1 block has staked a promise that has 10,000 ETH, maybe it's not 1,000,000 ETH, but 10,000 ETH, that's still a pretty good, strong, economically backed promise that it's going to do something that you want it to do. And in fact, if you get many proposers to cooperate together, this is called distributed validator technology, and participate in that role together, and now you perhaps have like 1 million or plus more ETH staked behind that promise, that's getting to the level of economic security that Ethereum has. And ultimately, at the end of the day, you know, if something goes wrong, then Ethereum, if you wait long enough, will provide ultimate finality on what happened.
Awesome, Josh. Does pre-conf exist in the Celestia world, and what do you think about pre-confs?
I guess my view at a high level is like a pre-conf is the same thing as a sequencer. Like a pre-conf is like a base level. It's like, I am going to give you a guarantee of like, you want to do whatever. I am a person. I am like, blessed. I am enshrined, whatever. I'm going to give you a guarantee that a thing is going to happen faster than some, pre-implies that there is somewhere where like true confirmation happens. And in a roll-up architecture, we'll assume like the L1 is like the true kind of confirmation on like 15 minutes, whatever. On Ethereum, the pre-confer is just like a sequencer in this case, right? And we just say, there's one entity, and this entity is allowed to make promises on like what happens on that. We're just assuming that they will go post the data and like a state root, and theoretically there will be challenge mechanisms, and on some chains there are validity proofs for that. So again, I just feel the same. So to some degree, I view like a shared sequencer as like giving a pre-conf. I'd argue like how we think about the like stack of kind of like transaction submission, like order flow, whatever we want to say. Generally, we assume in like a roll-up system, you're going to have like a sequencer entity, and then I think one of the questions as you decentralize sequencers or look at shared sequencers, to Ben's point about these like, whether it's like an enshrined builder who has to like put up like collateral, or we've termed like super builders before, right? This entity that is responsible for like simulating transactions across multiple distinct state machines, and then they are getting a like pre-conf of like the settlement of this on a sequencer chain, and then we assume there's like final finality, right? We've used that word too much, on like a base layer below that. So I guess there's like multiple layers to this, right? I've defined like in my head like a sequencer as like the first useful point of finality, right? And again, that is like, what does that mean, right? Like you're using the word finality in multiple places. From a user perspective, right, to some degree they might expect finality when they say, well, I pinged my like whatever, like Infura RPC node, and it says like, I see your transaction. They're like, good enough for me, right? You see this in like TradFi as well, right? Like a user goes, you tap your card or whatever, you buy a coffee, right? Like when the hell does that settle at like whatever clearinghouse or the Fed? You're like, you just don't give a damn. That's going to happen somewhere else later. So there's like layers to finality, and I guess like pre-conf as a general term. Usually it's used to define like using like L1 proposers to provide some kind of commitment over presumably like a roll-up kind of transaction. And my argument is like that's the same thing as what sequencers are. We're using different words. There's some subset of entities running a binary that is presumably marginally different than the L1 binary, and presumably they run this binary faster. And like many different ways you can have implementation details for that.
Awesome. Just for a reference, Josh made a talk, had a talk yesterday. It's called Shared Sequencer Incentivized Relay. So I guess we have many different words to describe sequencers now. Sam, I want to go to you. I want to like, what is pre-conf to you, like, from a roll-up developer perspective?
Yeah, for sure. I want to actually share kind of a story in the field here, because we've been out here at ETH Denver. It's actually my like fourth talk in 3 days, so excuse me if my voice is a little bit dying. But basically, with Fraxtal, the way that we build it is that there's actually on the block space layer, there's these things called block space incentives, and the way that you can think about them is it's EIP 1559, but instead of burning tokens, you actually reward points to the most popular contracts, whether they're L3 contracts, DA contracts, or anything. And so what's really interesting is it's actually built right into the actual chain. And so we've actually had 3 different projects approach us this week and say, hey, we're really interested in settling on Fraxtal. Same way some people are starting to settle on Base, right, the Coinbase L2. And their question is, for example, how much does it cost to settle on Fraxtal? And the answer is it costs negative, right? If you're actually a hugely important contract, like an L3 contract, you'll actually get a lot of the tokens distributed to you through the block space incentives. The second question is, like how is Fraxtal built if we use an Arbitrum SDK or Polygon CDK? Is that possible? The answer is yes. The goal is we're trying to be really unopinionated about how we build all of these things. And so the next answer, or the next question is, we want to use Celestia DA. So like 2 projects have already told us that they want to use Celestia DA. Can you, does settlement work with Celestia, or is it only with EigenDA, Dankun, Ethereum, or something like that? The answer is also yes, right? So the answer here is when we try to build the best settlement layer, our view, and it's kind of showing that it's been very effective, at least so far in this week talking with projects, is that you combine incentives and unopinionated tech stack to actually coordinate, as everyone's saying, coordinate around one place where value gets settled. And so one of the main things we like to say about Fraxel is it's an M2 chain, not an L2 chain. And so with people that are in economics, M1 money is like Ethereum, it's cash, it's coins, it's Bitcoin. M2 money is one layer of hypothecated value. So it's like Lido Steth, it's Frax Ether, it's WBTC, it's money market accounts, it's stable coins with yield. And so our goal is to be the least opinionated M2 chain, or maybe even the first of all M2 chains, and settle that value across all types of frameworks.
I want to push back on the question again. What's your thoughts on pre-conf then, given that context? Or have you ever thought about it?
So honestly, we're trying to actually do research in this area, and like the sequencer kind of conversations have been just started with Espresso and everyone. So right now we just launched 3 weeks ago. So we haven't really formed a very, very valid opinion on it. So,
that's great.
Yeah.
Adrian, pre-conf is very much an Ethereum right now oriented concept. How do you see it from your side of the world?
I think generally speaking, we should be building systems that have fast finality, not in the order of minutes, but rather in the order of seconds. So this is not hard. There's like consensus algorithms that do this at scale globally. This is like not going to be the biggest problem. Pre-conf to some extent, I mean, like once you start having multiple possible block proposers, you can have weird front-running attacks where like users try to blow up proposers where if I know that you're not necessarily the next one in line, you can still give me, I guess, a pre-conf. Now I can front-run myself to get you slashed. Like, I'm just always skeptical on trying to circumvent the underlying finality of the actual settlement system, simply because we have fast finality settlement systems nowadays, and the incentives and economics and security guarantees that we get from sort of like building more abstractions on top of this and more sort of rehypothecation on top of this are very hard to pass as an ordinary user. So yeah, I would prefer if we move away from a world where like we sort of pretend eventually this will be final and I have to double check this, to rather a world where we have fast finality all the time. And this is not to say that we need to have fast finality globally. I think actually the other trick is we shouldn't have this much shared global state. Really, like if we do a bunch of transactions in Denver, there's no point to like globally order these transactions with New York. Why the fuck are we doing this? This is clearly idiotic, and no scalable system is going to be built this way. So we should really like minimize the amount of shared global state we have to sort of the minimal subset. And for transactions ordering or trading in Denver, we don't need to globally order this with all other trades happening on the other side of the world, right? And this also makes building scalable consensus systems way easier once you start actually sharding your state and your ordering guarantees into heterogeneous trust models that more actually reflect like physical or digital realities. I mean, this can even apply to something like World of Warcraft. If you want to build a game and you want to use some decentralized tech, like it's kind of weird that you want to be settled with respect to like Denver transactions for your World of Warcraft transactions. You rather want to have a security model that reflects your actual like connectivity tissue within your social graph.
Awesome. Go back to the sequencers. Josh, I want to start with you. What are the biggest pushback when you're talking about shared sequencing or decentralized shared sequencing from specific, app chain rollups, and how do you normally respond to these, concerns?
Yeah, I guess like one thing is like the cynical position, which is like these people just don't give a shit about decentralization. Like people would just be like, I will care about decentralization when my legal counsel tells me that I have to care about decentralization is like a concern. Until that moment, I see the Dune dashboard for like roll-up economics. I see the bar charts. They're different colors. They run centralized sequencers. I see that Base is making $1.5 million of profit per month. I would like to be a different color bar chart on that graph. And I think the easiest way to do that is to run one node, and to run that node quickly, and to make money, and to keep all that money for myself.
And that's very true. This is like the valid take, actually.
Yeah, and I guess that's like a valid take. It's just like, my pushback is kind of like, cool while you're here. Like, there's like a lot of good podcasts from like the Jane Street guys on like how they do like replicated state machines. And if you like listen to that podcast, you're like, yeah, that's just like a sequencer. And it's kind of nice because like they just run their thing. They go for like whatever, like a trading day. You know, they open like 9 a.m., they close like 4:30 p.m. They run it. They get like 4.5 terabytes or whatever of data that goes through this. It's like one box. They run it at like 1 million TPS. At the end of the day, they take a state snapshot. Next morning, they spin it up. It's also very nice. You get to go home at 4:30. You don't have to worry about your sequencer running. So there's kind of this question of like, look, it's fine if you don't give a shit about like decentralization, but like there is like a robust domain of people who have spent a lot of time optimizing how to do replicated state machines in a centralized capacity. They are hiring. They pay quite well, as I understand it. You can go get a job there. If you want to do things in a centralized fashion, maybe go to the centralized finance industry. If you want to do things in a decentralized fashion, fundamentally, you're going to have to accept some technical trade-offs, and you're going to have to do that for like some ideological reasons that you think that is fundamentally valuable. Again, fine if you don't care about that. Maybe here is not the place to do it.
Great, great. Ben,
So this pushback is something that we hear all the time, right? That chains are sovereign, they have their revenue streams. Why would they give that up to a shared sequencer? That's like the most common overheard thing. And you know what? It stems from a misunderstanding of what shared sequencing is. Or you know what? I think that the shared sequencing that I talk about is different than the shared sequencing that you talk about. Because Espresso is not building something to replace sovereign chain sequencers. It's not at all doing that. And maybe we messed up. Maybe we messed up by calling this thing a shared sequencer to begin with. There's a lot of terms in the industry, and terms evolve. The reason why shared sequencing, in my view, which is I view as more of a marketplace, is not taking away revenue from sovereign chains, is that it's actually a mechanism through which chains can sell their block space on the open marketplace to other nodes that will pay it more for that block space than they can make on their own. And why will they do that? They will do that because they're buying multiple block spaces across the industry, across rollups, and if you own the block space for Ethereum L1 and Arbitrum and Optimism and Base and all these other things, you can create surplus value from that, okay, by doing things that individual isolated sequencers cannot do on their own, like taking advantage of arbitrage between AMMs on different rollups, like promising to users that their transaction on one rollup will execute at the same time as their transaction on a different rollup. And this comes back to another point, which is that you hear two other polar opposite viewpoints. One which Adrian talked about a second ago, and the other is that, oh, well, shared sequencing is making all rollups one chain. All right. That's just one rollup, right? It's just one rollup. The other thing that you hear is, you hear people say sometimes that actually it's really easy to build one very fast finality consensus protocol that does all this. That's not the hard problem. These are two polar opposite extremes, and anyway, this is my personal view. I think both of those perspectives are wrong. So fundamentally, having different rollups means having different execution environments, right? There aren't going to be, this is horizontal scalability. This is what's scaling Ethereum, right? We're not going to have one large collection of nodes that are executing for every single different rollup. You may have some specialized nodes that are able to execute for both Optimism and Arbitrum, and because they're that specialized, they will buy the rights to propose blocks for Optimism and Arbitrum together, and they will be able to create surplus value from that. But that's not something that the entire ecosystem of validators is going to do, right? If that was the case, we wouldn't be having rollups in the first place. We would just be scaling Ethereum. This other thing, on the other side of the spectrum, is when somebody says fast finality is really easy to achieve over everything, you know, if they're talking about fast finality over state, then they mean that we're not horizontally scaling execution. If they mean there's fast finality over just transaction ordering, well then it brings into question what we mean by fast finality. Right? If I get a confirmation from a consensus protocol that my transactions on Arbitrum and Optimism are both done, they're done, it doesn't tell me what is the state of Arbitrum, what is the state of Optimism. I don't know if my bridge transaction succeeded. Right? And that's why I need to rely on an intermediary who's executing for both of those systems to tell me that. Until some common protocol settles this, and that is Ethereum, but it takes 15 minutes to do that, because of fundamentally how Ethereum is built, to be a dynamically available system that doesn't need to tell you what the state is of the system immediately. So that's my view, right? That shared sequencing is the obvious solution when you want to maintain a horizontally scalable system, which is the future of Ethereum. When you want to have sovereign chains, which are owning their own block space, what you want to do is create a marketplace through which they can actually sell that block space to specialized parties who are able to do more with it than they can do on their own.
Awesome. We're out of time. I want to get one more question in. You only have, I want to hear, after the panel from Sam, what do you want the audience to think about? One question or one thing you've learned? Either way.
Yeah, that's a good question itself. So the main thing is there's a lot of definitions of shared state settlement. There's all these views, like it was said before, where is DA kind of the Schelling point of everything, is settlement kind of the Schelling point of everything, and I think the way that we think about Fraxtal and just what we're building in Frax is a lot of those questions, the reason they're so blurry is kind of dependent on where the root issuance of the assets are, whether they're Ethereum because ETH is money, right? Or whether it's like a stable coin that's extremely important if it has its own rollup and it's a sovereign rollup or it's a shared sequencer rollup. I think the main thing people should think about is a lot of different definitions of things, of Schelling points, finality, or actually scaling computation horizontally. But the why is also very important, right? And the most important thing with Frax when we build is we think of where the asset lives, where the value is, what's actually money, and obviously ETH is money.
We are really low on time, so everybody only have 15 seconds. Go.
It's all about trust models. This is really the only thing that matters in the space. What it's hard is if you want to be in a trust model with lots of different people at the same time, it becomes expensive. So the question for me long term becomes, do we really want to have a one world government to rule us all, or do we want to have multiple heterogeneous trust models?
Ben, 15 seconds, go.
Trust minimization and decentralization is what this is all about, but what it brings is an interoperable unified system where we can have one global system where everyone is able to transact. That differentiates it from Web 2, which is fragmented because of lack of trust.
I was like, layers are good for network topologies. There's a reason that's how Web 2 works, and it's good to have economic specialization of different roles in a system be done by different actors.
I learned pre-conf is mainly still Ethereum concept. All right, thank you everybody.